Hi guys, and welcome to video 18 in the But How Do It Know companion video series. Today we're going to be adding the clock and stepper to our project board. So as we saw in the last two videos, the clock and stepper are really important parts of our CPU, as they will allow us to synchronize events happening as the CPU executes instructions, and make sure that everything happens when we want it to happen. So the clock and stepper are going to occupy this area right here. We're going to need to add a new Arduino here, Arduino E2. So if you haven't added it yet to your project board, you can do it now, and make sure you program it with the Arduino E2 sketch before adding it. So let's take a moment now and look at the schematic in more detail. So this is what our clock and stepper module is going to look like. So the first thing we need to do is add our third Arduino to the project board. Before you add it, make sure you program it with the sketch Arduino E2 and connect it properly to the previous one using the two white wires that you see right below it. Now let's take a closer look at the inputs and outputs for our clock and stepper module. So starting in the top left, we have the clock outputs, clock E and clock S. So those LEDs are going to indicate in which step of our clock cycle we're at. The next 6 outputs are going to be used to indicate which step of the stepper we are currently executing. To the right of that, there is a push button. So our clock will be initially in manual mode, so we will need to push this button every time to make it advance by a quarter cycle. So this will be very useful at the beginning, so we can get to inspect everything that's happening at each quarter cycle. And later on, I'll show you how to make the clock automatic so that we don't need to do that all the time. And finally, there is a last output signal, which is labeled wait here. And the idea is to tell you that the computer is ready and it can receive the next clock push when you're ready to do so. At the bottom, we can see that there are 4 inputs that are connected here using white wires. So those are going to be used a bit later in the project. So for now, just make sure you connect them using the pull down resistors as shown here, so that those inputs do not pick up spurious signals and make the Arduino misbehave. So I'm going to go hook this up and then we'll try it out. So everything is connected exactly like in the schematic, so let's turn it on. So when the manual clock starts, it positions itself right before the beginning of the first clock cycle. So as you can see, all the signals are off and the waiting signal is on, indicating that the clock is ready to receive a push signal from us when we're ready. Let's do that. So by pressing the push button, we have entered step 1, and we are in the first quarter cycle of step 1, so the enable signal is turned on. Now if we press a second time, now we enter the second quarter cycle of step 1, and our set signal comes on. Quarter step 3, we return back to having only our enable signal turned on. And quarter step 4, everything is off, just like in the diagram from page 96. So if we continue pressing, we will see that we will advance through each of these quarter steps. Now we're entering step 3, step 4, step 5, step 6, and reset. We get back to step 1, and we continue as such. So that's basically how our clock and stepper are going to work. And in the next video, we're going to go and have a look at doing something useful with our CPU.